Introduction. Most people never finish the books they buy. So here is 5G Core Networks summarized for you, the powerful ideas and key takeaways all in one place. Here is what is coming up, a quick overall summary, then a section-by-section breakdown of the most important points. Overall summary. The 5G architecture itself consists of two parts: the new radio network, NGRAN, supporting the new radio, NR, and the 5G core network, 5GC. Network functions utilizing service-based interfaces. One network function acts as the service producer, another one as the service consumer. Illustrates the core components of any 5G network. Mandatory components of a 5G network architecture. Connecting the core network to mobile devices and radio networks. The description above outlines the key parts of the core network architecture. N2 is a key reference point in the 5G network architecture. Chapter 1: Network and Services. The final section of the chapter outlines the structure of the book. 5G, 5G Core, 5G Networks, Introduction. Chapter summaries: the telecommunications industry has embarked on a dramatic transition, and one that, if successful, will see it redefine its role in industry and society. 5G, while often portrayed as a tool for higher speeds or critical to the development of the so-called industry, represents a foundational shift for wireless communications, one that places it directly at the center of a truly digital economy. Both have changed considerably compared to previous generations of technology. This book focuses on 5GC, providing short forays into NR where it aids understanding of the interactions towards the core network. A detailed description of NR is, however, beyond the scope of this book, and interested readers are directed to Dahlman et al. The first broad-scale adoption of mobile technologies started with GSM, 2G, released in 1991, which focused on calls and text messaging. It was not until the introduction of LTE, 4G, in 2008, however, that we saw the broad adoption of mobile broadband, MBB, and the uptake of video and data traffic on the all-IP network, including the development of apps on smartphones. Each generation saw a large increase in bandwidth and speeds provided, with end-user consumers as the core focus. 5G is unlike the previous generation of networks. It represents a shift from operators having end users as customers to, over time, having industries as their main customers. 5G is a more ambitious approach to network architectures, not only incorporating requirements from the telecommunications industry but other industries, and at the same time including cloud-native and web-scale technologies such as HTTP. It is quite simply a new approach to developing architecture and delivering services on a global scale. Broken up into building blocks covering access, transport, cloud, network applications and management, including orchestration and automation, 5G systems aim to provide a higher level of abstraction designed to simplify network management and operations. In addition, new services will need to be rapidly implemented on the network as new business models emerge that demand operators move to programmable, software-based networks that deliver services on demand and in an as-a-service manner. In addition, where previously human customers were making requests of the networks, with 5G there is an increased level of non-human, i.e., machine and software, requests. That means the entire way services are developed and delivered needs to change. The initial work on defining the requirements and vision on 5G networks was carried out in ITUR in 2012. The initial work to develop the 5G specifications to meet the ITUR IMD 2020 requirements was done in 2014, picking up speed in 2015 and 2016. Outlining the core network evolution in an easy-to-use and accessible manner so that engineers and other interested parties can understand the changes brought about by 5G is therefore the core reason for us writing this book. Several early commercial 5G systems became available already from late 2018 and early 2019. Some initial 5G network deployments include Verizon and AT&T have both launched USA's first 5G services during 2018 and 2019. Telstra has rolled out multiple 5G areas across Australia during 2018 and 2019. Services targeting enterprise use cases launched by all three Korean operators by the end of 2018. Early EMBB services were launched in Korea, the US, Switzerland, and the UK in the first half of 2019. 5G Core is described in a set of specifications developed by the third-generation partnership project, 3GPP, and captured in Release 15, REL 15, and subsequent releases. REL 15 was the first full set of 5G standards and was released in several steps between June 2018 and early 2019. REL 16 is planned to be released early 2020 and planning of work has commenced on Release 17 with an aim to have specifications ready in 2021 or 2022. Chapter 2, Network and Core. Part 1, Introduction, Architecture and Scope of Book. Chapters 2-4 provide an introductory overview and scope of the book. This includes modeling, session management, mobility, security, QoS, charging, network slicing and dual connectivity solutions. Chapters 13-15 provide the in-depth knowledge required for all practitioners in the 5G space, going into detail of how the core concepts in Part 2 fit together and work as a unified whole to deliver the 5G core network. Readers are presented with deep dive into network functions, reference points, protocols and call flows. 3GPP-TS, 3GPP Technical Specification, 3GPP-TS, 3GPP Technical Specification, General Packet Radio Service, GPRS, Enhancements for Evolved Universal Terrestrial Radio Access Network, EUTRAN, Access. Critical new technologies such as virtualization, cloud-native, containers, microservices and automation are also covered, illustrating how all of these combined with 5G NR provide for a dramatically upgraded network that can deliver services across enterprises and industries as well as to end-user consumers. The drivers for 5G are far more, therefore, than merely the drive for a new core network, but rather the result of intersecting requirements and demands, namely, 1. Business case demands from a broader set of economic actors, including industrial companies driving new use cases. 2. New technologies for delivering core network components, creating expectations of more efficient and flexible operations. And 3. Shifts in how business, society, and environmental needs are balanced to deliver services in a new way. The enhanced user experience is mainly experienced as overall higher data rates, not so much about higher peak data rates, but more about providing an increased average data rate across the network. Users of mobile broadband services will therefore experience a higher quality of service. On the network operations side, meanwhile, expectations are that the new 5G network architecture would give additional benefits in terms of increased support for automation of various operational processes. This could be, for example, network capacity scaling, software upgrades, automatic testing, and usage of analytics to optimize network performance. This adds to the interest for 5G among some service providers. One of the initial key drivers for the new 5G core architecture and the associated principles for access technology independence was converging the operations for various types of technologies. The network element architecture is distributed internally onto specific types of blades that perform specific tasks. For example, blades that execute software that is responsible for overall management of the network element versus blades that perform the actual work of managing mobile core subscribers. ETSI-NFV, Network Function Virtualization, and OPNFV was created to facilitate and drive virtualization of the telecoms networks by harmonizing the approach across operators. The network element could then be realized as an application that is distributed among several virtual hosts. For example, the operator can deploy much larger, or even much smaller, instances of the network element. The next step in the mobile core architecture evolution is to a cloud-native design to take advantage of the flexibility offered in using cloud technology and capabilities. In this step, the mobile core network element design that was tightly integrated together in predefined units and ratios is now decoupled both logically and physically to provide greater flexibility and independent scalability. For example, this step sees further separation of control plane and user plane of a network function. Also, in this cloud evolution, mobile core functions begin to implement the network architecture of web applications. It is often considered a variant of the service-oriented architecture approach. Chapter 3: Network and Architecture. 5G, 5G Core, 5G Networks, 5G NR, Architecture, Non-Standalone Architecture, Service-Based Architecture, REST, Policy Control, Mobility, Voice, IPS Fallback, Messaging, Devices, Public Warning, Network Slicing. Work on designing and specifying a core network for 5G was done in parallel with and in close cooperation with the teams designing the 5G radio network. Previously, when new access network generations were developed, each one had a different functional split between the core network and the radio network, as well as new protocols for how to connect the radio and core networks. It instead comes with a new set of interfaces defined for the interaction between radio networks and the core network. Essentially, this means that any access network that supports N2/N3 could be connected to the new 5G core architecture. The key document for the technical study on the 5G network architecture in 3GPP is the Technical Report 3GPP-TR. The fact that LTE access support is specified for the new 5G architecture means that an LTE access network in practice has two ways of connecting with a core network, potentially simultaneously and selected on a per-device basis. Using S1 connectivity to an EPC core network, note that it is not only the network interface and associated logic that needs to change when migrating from S1 to N2/N3, but connecting LTE to 5G core also requires a new quality of service concept that impacts the radio. Scheduler. When defining the 5G radio access network specifications, two variants of combining LTE and the new 5G radio access technology, NR, were discussed. In practice, it relies on LTE radio access for all signaling between the devices and the network, and on an EPC network enhanced with a few selected features to support 5G. The possible combinations of 5G radio and core networks. The formal name of the NSA radio network solution is ENDC, short for EUTRON NR dual connectivity. In subsequent sections, we describe the details and logic of each network function as well as the protocol specified for different parts of the network architecture. Concluding this chapter is a brief overview of the 5G radio technology and network architecture in section. The user data processing parts, as well as the integration with 3GPP radio access networks, are quite similar between the new 5GC and the traditional EPC network architecture, originally defined for 4G per LTE. The first visualization shows the way different network functions are connected. For each interaction between network functions, one of these acts as a service consumer, and the other as a service producer. 5G core architecture visualized with service-based interfaces. Firstly, however, let's look at the other visualization of the architecture that illustrates how network functions interact with other network functions, represented by traditional point-to-point interfaces. Showing these interfaces can be useful to illustrate which of the network functions that utilize, or consume, the services of which other network functions. Another difference between the two ways of representing the architecture, apart from illustrating how different network functions interconnect, is that some network functions are only applicable in one of the representations. The two network functions NRF and UDSF are visible, highlighted in black. A major difference in 5G core compared to previous generations of traditional network architectures represented by nodes or network elements connected by interfaces, is the usage of service-based interactions between network functions. This means that each network function offers one or more services to other network functions in the network. In the 5GC architecture, these services are made available over network function interfaces connected to the Common Service-Based Architecture, SBA. Chapter 4, Network and Service. Shows 3GPP network functions utilizing HTTP REST for service-based communication. When two network functions communicate over the 3GPP SBA architecture, they take on two different roles. The network function that sends the request has the role of a service consumer, while the network function that offers a service and triggers some action based on the request has the role of a service producer. In the 5GC architecture, this registration is done to a dedicated network function that is called the Network Repository Function, NRF. This concept allows the NRF to keep track of all available services of all network functions in the network. During the actual registration, the PCF acts as a service consumer, and the NRF as a service producer, basically offering the service of network resource registration to the PCF. Now the PCF services are available to other network functions through querying the NRF. In this case, the AMF is the service consumer and the NRF is the service producer. A network function typically registers with the NRF when it is put into service, while the service discovery and service requests may, for example, take place when a device connects to the network. This is based on the fact that one or several network functions can subscribe to a service from another network function. Having described the new mechanisms for how different network functions communicate, let's now return to the functional view of the network. The core functionality of the network architecture includes functionality for establishing sessions in a secure way and to forward user data to and from mobile devices, providing data connectivity. In addition to radio network and the NRF described in section, it includes the following 6 network functions: FIG. Connections towards all other network functions are managed via service-based interfaces. The AMF is involved in most of the signaling call flows in a 5G network. The SMF interacts with other network functions through producing and consuming services over its service-based interface, but also selects and controls the different UPF network functions in the network over the N4 network interface. In addition to this, the SMF has a key role for all charging-related functionality in the network. Furthermore, the SMF interacts with the PCF network function for policy control of user sessions. The UPF can also apply quality of service (QoS) marking of packets towards the radio network or towards external networks. Important data is of course the subscription data and data defining various types of network or user policies. Usage of UDR to store and access data is offered as services to other network functions, specifically UDM, PCF, and NEF. The connections to the radio network and the devices are shown in FIG. All signaling between the radio networks and the core network, fronted by the AMF, is carried across this reference point. Chapter 5: Network and Data. One difference to the EPC architecture is that for 5GC, also the reference point between the device and the core network, the AMF, has its own name. This concept is further described in section in the context of network slicing. As described above, user data is handled in the UPF, the user plane function, in the core network. Data is transported between the radio access network and the UPF over the N3 reference point. N3 includes a new way of managing the quality of service of specific data flows and how to map data flows to tunnels. The reference point is called N6 and corresponds to SGI in the EPC architecture. For Ethernet sessions, N6 is a layer 2 link instead of a routable IP network. Shows the interfaces related to user data processing and transport in the 5G architecture. The user plane connection to radio networks and external data networks. SSC Mode 1 means that the IP address is maintained regardless of movements in the network. The same IP anchor point, UPF, is accessible and can be used across the network. The network will release and trigger the device to re-establish new sessions as the device moves around in the network. The network decides to release the session based on operator policies, for example based on a request from an application function in the network. One example is if a service requires very low network delays while being implemented in a network covering a large geographical area. For a device to access such a service, the subscription used for the device need to include the corresponding LADN service support. If this is required or not depends on the operator network configuration, specifically how the transport network between the base stations in the radio network and the various core network sites has been designed. The UPF1 will be selected and be serving as the IP anchor for the device, connecting to the internet or another data network that offers some end-user services, e.g., IMS. The device then moves to another part of the network, where the radio base stations cannot connect to UPF1 due to limitations in the transport network configuration. For this to work, the ULCL function must be applied in the UPF closest to the access network. In the downlink, data flowing towards the device from both the centralized UPF and the local UPF is combined into one single data stream in the UPF closest to the access network. The ULCL function is controlled by network rules provided by the SMF that manages the specific IP session. The 5GC architecture includes extensive functionality for policy-based control of traffic and user services. PCF connections to other network functions. Closing. That brings us to the end of our review of 5G core networks. Thank you for listening. If you found this helpful and would like more book summaries like this, please subscribe to the channel and turn on notifications so you never miss a new video. Tell me in the comments which book I should review next, and I will see you in the next one.